D are C and B and D naught are B naught and A. So I can first start by drawing this circuit out. So I see that I have A, B, C naught. So I'm going to draw all my inputs. And we got naught C first. Then we're going to add them together. Then we're going to add A and D together. Then we got B, C, B, D naught. So C goes down, E goes down, D naught this. And them together. Then we have B naught here and A. Then pour them all together. So, this one question is to give you the function drawn in the circuit of this function. Say, can this function be reduced? We can reduce it using our Boolean algebra that we did before, or we can use it using Karnaugh maps. So, once I want to see if I can reduce this circuit down, so then I just fill in my truth table for the various inputs. So I can do it either 0, 0, 0, put all in here. So 0, 0, and not the 1 there. 0, 0, 0, 0, not is 1, 1, 0. And that all together, we get 0. Output is 0. If I do 0, 0, 1, so D is now 1. That changes to 1. That changes to 0. Didn't change anything. The results to 0. So that's 0. I can also use the circuit, so I can do 0, 0, 1, 0. And we can 0, 0, 1, 0. We go through inside of 0, 0 and 0 and 0. 0, 0, 1, 0. That's 1, that makes that a 0. 1, still 0. That's a 0. We're all the zeros together, and we got 0. So that answer is also 0. Right. For time, I'm just going to fill it in for us. So the rest of them are go as so. So I'm going to label these again, as we did on the other Karnaugh map. So, and 0, and 1, 4, 5, 6. over here, do the same thing. So this is M0, M1, M2, M3, M4, M5, 6, 7, M8, M9, 10, 11, 12, 10 down here, 11. You understand how I got these columns? Basically, if you look at it, see AB11 and C11, which is basically this right here, M15, which is what we got right here. So basically, to match up my columns with the bits that I'm inputting. So then we fill it in. We got 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0. Okay.
Can you write the M numbers bigger? I can't read them.
It's just columns. Like I said, just match them up to. Like I don't even care if you use them in your Karnaugh map.
You just have to make sure that the numbers from that match up with the numbers from there. So
Yeah.
like 0, 0 has to match with the zeros on that one. So it happens to be M0 on that one. So he's just taking the value, the output.
These are probably the worst ones here. Is that better?
Yep.
Right. So now I can find my implicates, or my groupings. So how can I group again?
Power to 2.
Power of 2, okay. We want to do largest first. So do I have a group of 16 that I can circle? I have a group of 8 that I can circle? No. I have a group of 4?
Yeah.
Alright. So I have that group of 4 I can circle. I have this group of 4 that I can circle. And then I have these 4 I can circle. Because once one of these ones is circled, if I don't have to circle again, I don't want to circle again. Like if I had, like this one here is covered by every single one of them, but I'm using it so that way I could basically reduce as much as I can, yeah. So basically we look at the groups, again, the same way we did the other one. Here we see that B is the same. We see that C is the same, but our D and our A, we don't care. Basically, it can be 1 or 0, as long as but C and B have to be 1, or the output to be 1. So we know that as one of our implicates. So we know that this was C and BC, yeah, BC. Alright. I'm just going to go simply down to the final answer. So, or with the next grouping, see this grouping here, we see that.
Wait, I don't understand how we got that.
BC? Okay, so look, this grouping right here. So this is A, this is B, this is A, this is B. You see the A is going from 1 to 0. So it could be either 1 or 0. B has to be a 1, right? And see over here, the same thing. C has to be 1. D could be either a 1 or a 0. So basically, if I AND an A with B with C, which are 1s, my output's going to be 1, right? So I'm going to fill in my table with 1s, with D just ANDing B and C together.
So this is a table of just ending together.
Yeah.
You're creating 3 terms because you have 3 circles.
Yeah. And so I'm going to do the same thing over here. This grouping is you see that A and B, they have to be, their output has to be 1, which is ANDing A and B together will be 1. And we see that C and D, doesn't matter what value they are, the output's supposed to be 1. So we know this result here is AB. And then we see through this grouping here, we see that A is 1, and B is changing from 1 to 0, so we don't care about B. And over here, we see that D has to be 1, and with C we don't care, so we know it's AD. So then we OR all these results together, which basically is, like I said, if I go, if I do, let's do 1, 1, 0, 1, so which is this cell here, I put this in, so B is 1, C is 0, A is 1, B is 1, A is 1, and D is 1.
And where did you pick those numbers up from?
I just picked, basically is my input, this is my input, this is my new input. I just put this in, so I'm going to test this equation to see if it verifies the correct output. So I just put the output onto the equation.
It's the second row, third column that you're working on.
Yeah, it's this one, so it's M13 is the input or result. So we can see we end it, this is 1, that's a 1, and this is a 0, but we OR 1s together, which would be 1. So we got a 1. If you want to look at it is, well, we see that this was a 1, this is a 1, which is this circle here got a 1, and this circle here got a 1, and so that's why I got 2 1s in that equation. So basically, this equation here reduced down to just basically my circuit now is this. Let me erase this.
You're building the circuit for the input 1101?
I'm building this
circuit.
Oh, for the BC.
So this is like, I'm going to do F function 2, F2. So basically, this is our new circuit.
Simplified circuit.
I see. If you put the input through that circuit, it can know.
So we got A ANDed with B, we have B ANDed with C. And then we have A down here. We have A and D. And just pour those together. Okay.
It's a much simpler circuit.
Much simpler circuit. And think about it is 1, 2, 3, 4. I use 4 gates. We use 1, 2, 3, 4, 5, 6, 7, 8 gates. So this is a lot more expensive to build than this one. And so, like I said, we want to use the cheaper one. Any questions?
Dummy race.
Okay. No, I'm gonna erase. No worries.
Pretty quick with the answer.
I have a question.
Yeah.
So when you made your table, how did you know to put the 1,
This
1
over here?
before the, yeah?
basically when we build these tables, we only want one digit to change. So here, B was the only one that changed. Transition from this column to this column. And then with this column, only A changed. B stayed the same. And then over here we see that only B changed and A stayed the same. So we want to keep the same groupings, the same way we did that way. That's because if I do like a regular truth table, we can't do the groupings
Yeah,
that
I
we did.
noticed that. And when you include all your ones, are you gonna wanna include all the ones? Like if you have an outlier, say 0, 0,
Yeah, if I put a 1 out here,
does that have to be included or does it not need to be included?
yeah. If I put a 1 here, what I have to do is now I have to circle this. I can circle those two. Okay.
And how, that's not gonna get you one.
No, then what's going to happen is, so we get A has to be a 1, B has to be a 0, and
No, you mean A has to be a 1 and D has to be a.
no, yeah,
or
yeah.
C has to be 0, whatever.
Yeah, A we don't care because it's either one. B has to be 0, C has to be 0, and D has to be 1. How do we do that? So we go over it with B naught, C naught, RD.
Now you just made a larger circuit.
Yeah, just so I can include, basically, I wanted that to be 1, so I had to add that to make that a 1.
So the whole point of this, Ryan, is to use this table in order to make it a more efficient circuit
Yeah,
and a cheaper circuit.
yeah,
So originally you had that, which is
Yeah.
in green.
yeah. Here, this is the original circuit we had. And then we filled in all our inputs, found what our output was. We filled in the table, and then we started grouping them up, and then we were able to get a smaller equation.
Is there a place that we can go for a tutor for this?
No, there's no tutor for this class. Like basically, it's after class or before class. I can help you out.
How complicated are the circuits gonna get on the test? Like, are you gonna have us doing this like efficiency?
No, you won't have. Basically, if I get any bigger than this,
Yeah.
you're going into different dimensions. We have to make this go out this way,
Yeah,
and so we're not going to do that.
okay.
Basically, 4 is probably the worst to get. Most likely, you'll have 3. You'll have 4 on the next.
It doesn't matter how we build it, or do you want us to go by this like graph?
I would go by this.
So build it off of that.
Yeah. So, assignment, I believe it's 5, where we have a 7-segment display, which is a light system.
I think this is it.
And if you do it your way, you can memorize just those M's, basically.
Yeah.
Where your M's would be, if you did it that way, where you flipped the order of, the third,
Yeah.
I guess, binary or.
Like when we flipped, we kind of looked like this, went down here, up here. And then when I went from here, M6, I went up to M7, then went to M8, M9.
If we follow your order, those M's will always be
Yeah.
there.
As long as you keep this in order. Basically, this is your first input, second input, third input, fourth input.
Are there any practice exercises anywhere that
Um,
include the answers?
I believe, I have to look at the note sheet again that I have. There might be some examples, there's more examples there, and there might be some, I would basically use it as a sample. Like I said, also a little program that's in there as well. You can basically, you fill in, the table, and then it will create a Karnaugh map, and then it will do the circling for you. So that way you just see where the circling is.
Is that one that's
Like-
on the blackboard?
Yeah.
Okay.
So you could create your own problem and then solve it and then
Yeah.
use that little calculator to figure out if you got it right or not.
Yeah. So, that's a good test. I'll give one more for the hint for the assignment that we have to do this on. Let me explain. Explain it a little bit. So if you remember an old calculator back ago, or probably still one buy one today. They had what's called a 7-segment display. So you had basically you had, these are LEDs, these are lights. So basically a calculator, you know, if this was all lit, this would be 8, right? So basically what we want to do is you're going to have 4 inputs into this